Hi everyone. So I'm Mircea. Today I'll be giving hopefully a brief talk that's slightly more methodological in terms of how I approach this specific project, and it stems from kind of my philosophy in terms of what I think is going on in lie detection research. So the name of my talk is Uncertain Veracity Judgments, and I was focusing on the way we frame questions, like the way that we frame the question that we asked our judges to answer might impact the type of decisions that they make. And as you can probably see on the slides, let me get my little pencil-y thing. Uh, the a little spoiler is that the answer is no in terms of it does not seem to have an effect, but that's kind of part of my talk, and I'll go into that in a bit more detail in a bit. So what do I mean in terms of uncertainty and veracity judgments? The way we can conceive lie detection or the way we judge others in terms of their honesty or not has to do with an element of uncertainty. We don't really know what's going on, and it's very important for us to try to figure out the truth. But that can be very difficult because we are missing important information. Now, there are various schools of thought in terms of how we should be approaching this. For instance, some of those that refer to this as deception detection might see this in terms of there is an actual answer. So there's information hidden within what the person is saying, and our job is to basically pick up on that information. I take a different view, which is why I call these things veracity judgments, which I tend to focus on how people make these decisions. So when you have limited information or the information that you need might not be accessible at all, how do you actually collapse into the judgments that you make? So one of the things that I wanted to focus on is maybe the question and the way we operationalize our experiments might have an impact on people's decision making. Now, I thought about this because I see very often the deception research kind of takes this, let's just get it sorted type of attitude. Like, okay, we show people some stimuli, we give them some binary responses, truth or lies, we look at the data and kind of be done with that. But I thought maybe a bit of a nuanced perspective on the decision-making process itself might give us a bit more insight into what's going on. So I try to look at models dealing with probability and how people think about probabilities. And one of the things that normally stems from this is the various forms of uncertainty. So some of the uncertainty that we have is called aleatoric uncertainty, and the other type that I'll be dealing with is epistemic uncertainty. Let me just- Okay. So what do I mean by these? Let me just delete this stuff. Aleatoric basically means that there are always going to be situations when there's some sort of uncertainty or randomness to the process that we care about. So this is just natural randomness within the world, right? People could lie, they could tell the truth. The best way to see this is like throwing a die. The probability of that is set. If you know how dice work, if you understand how you can calculate these things, then you might have a better chance than somebody else. But the uncertainty you have in the outcome of your die has to do with the process, not with some sort of missing component. While epistemic uncertainty deals with a lack of human knowledge. So you don't know what's going on, you're lacking the proper information, but if you had it, things would get better. So ideally, we're trying to see if these two forms of uncertainty have an impact on how people determine if somebody's lying or telling the truth. So how did I go about this? A simple way in which people have studied this within the judgment decision-making realm is in terms of the language that we use. So we find that people tend to use the terms like chance, like what's the chance of this happening, to determine aleatory uncertainty. So they just think like, oh, there's a probability. This is what I think the probability actually is. Well, sometimes when they talk about epistemic uncertainty, we tend to use words like sure, like I'm sure that this is going to happen. I'm sure that I closed the door when I left my house. It's one of these things that has to do with your own knowledge and an internal belief system about that specific process. So it's slightly different from aleatory, which is simply the mechanism by which you think outcomes are derived happens to have specific rules, and you're just trying to figure out in your specific situation which one of the outcomes actually happened. Question framing is probably the best way to get at this. And one thing to note, because some of you in the audience might say, well, maybe this is just like a language thing, right? So maybe people use language, they're synonyms, do they really matter? we actually have a lot of research that finds that these are not just linguistic features. They tend to reflect, or at least have been argued to reflect and even affect our underlying cognitive processes as well as our motivational processes. So there are various frameworks that operate in terms of what is uncertainty, how do people think about this, and can we access different parts of our brain based on the way we frame specific questions. And we see that there are even kind of consensus in terms of how specific terminology and specific cultures tends to be perceived in terms of, let's say, probability. So my question was very simple. If I frame the veracity judgment based on these types of words, will it have an impact on what processes the judge is actually using to make their conclusions? So in the past, there have been a few studies that have tried to look at question framing more indirectly. I don't assume that this is exactly what they were trying to get at. So we've seen work on, for example, if you make judgments, if you're prompted to do a veracity evaluation versus not, if you frame the task in terms of this is a lie detection task or this is a truth detection task, that seems to have an impact, especially in terms of bias. Or sometimes people have thought that maybe if we ask questions indirectly, it's going to access a different part of our brain than the one when we do consciously. So I'm kind of leaning into that type of research, thinking more about how we operationalize the type of studies that we do and the type of impact these operationalizations are going to have on the outcome in our research. So my hypotheses are fairly simple. I have these two conditions that I care about. Either we frame things in terms of certainty or in terms of likelihood, and I want to see if this has an impact on the veracity judgment process. So either in terms of the probabilities that people give in terms of how likely an outcome is going to be, but also on the overall judgment process that we tend to know. So accuracy, confidence, and response bias, which are the main things that I think are normally affected by the manipulations that we see in the research that we conduct. So a bit about the methodology, because this is essentially what is the crux of my research. So I have a few things that I'm going to be measuring, or in this case have measured, which is the probability that judges think something is going to happen. Then I think in terms of truth and lies separately, but for the sake of this talk, I'll just aggregate them, even though it's not something that I would normally recommend. I'll focus on response bias and confidence, but the way all of these things are essentially collected and the things that are important are the boxes that you see at the bottom in terms of how the participants saw the actual question. So the modifications were slight, but the argument is that this simple linguistic tool is going to allow us to tap into aleatory versus epistemic uncertainty. So either we think that something is likely to happen, or we think that with a certain level of probability, we're sure that this person might be lying or telling the truth. So that's essentially what the manipulation is, the slight linguistic difference that is argued to affect these two separate systems. The procedure was rather simple, so I just showed people videos as you do in lie detection research. They weren't very long. Senders were just describing a past holiday that they actually went on or did not, so some of them were lying. I gender matched senders based on veracity, so there was equal amounts, and no sender was used twice, so just to control the randomness of the task. And then participants were basically split into two groups. Either they were seeing the epistemic version of the questions, or they were seeing the aleatoric version of the questions, and then they had to rate things based on a probability scale, as you saw. So I didn't have them use the scale per se. I had them input the numbers because I thought that would actually capture them thinking a bit about what it is that they were answering, while confidence was just judged by using an ordinal scale. But there's a small little caveat to this, which is that what about my uncertainty in terms of what's actually going on? I haven't done this type of research before, and a lot of the studies so far tended to be very mixed and not related to lie detection. So I think it's important to capture my level of uncertainty in terms of how this experiment is going to unfold. So to do so, I had to plan both for finding the effect that I thought might be likely, but also planning for no effect, which is essentially what the study was actually about, is me trying to conduct an experiment that would allow me to also measure no effects, not just statistically significant versus not. So as I mentioned, I had various reasons to believe that an effect might either be present or absent because there was a lack of research. Normally the results in lie detection tend to be very mixed or very unsure, and there's some elements of publication bias that we need to take into account. So what do I need to do in that case to also plan for the possibility that there's nothing actually going on? So first I have to take sort of an educated guess in terms of what I think would be an effect that actually matters. In this case, I just relied on what I know to be an average sized effect in psychology and one that tends to be compatible with lie detection research, which for those of you that know standardized effects is essentially a Cohen's d of about 0.4. So not very big, kind of a moderate size effect. However, I had to design the study so I could also reject effects that are smaller than this, because I planned that this is the only effect that I actually cared about. Effects smaller than this, I basically take as no effect. They don't really interest me that much. They might just be variations or something that I can't really translate or generalize. So that's the way I structured my experiment. So how do you normally go about this? Some of you might be familiar with the concept of equivalence tests, and this is essentially what you need to be able to make both of these claims. So the normal hypothesis testing just tells you if you think you have detected something, but it doesn't tell you if you haven't. The only way you can do so is with equivalence test. I'll try not to explain this in too much detail, and it normally tends to be very confusing the first time you try to figure out what's going on. But essentially, what is happening is you set some bounds around zero that you say anything that's happening here is basically no effect. Like small variations from zero, I would take as no effect. They're not really that important. So you set a lower bound and an upper bound. And then after you've conducted your experiment, if the effect of your data happens to fall neatly within this area of I don't care, you would take it as no effect. Anything that's slightly outside, you might take as I need more information to be able to be certain. Anything that falls fully outside, so if something was over here, you would say that I found an effect that I actually care about. So graphically, I think it makes a bit more sense. You're basically saying, I'm just hoping that my effect doesn't fall here if something's going on, or if nothing is going on, it's going to be somewhere here in the middle. So to do so, I had to plan for the comparisons that I actually care about. So what do I mean by this? Very often people, when they do a lie detection experiment, it's going to be at least a 2x2 interaction, because you have veracity, which is always going to have at least two conditions, and then you have whatever your manipulation. If you do this in, say, G Power, in my case, I just did a simulation in More Power, which is a similar app, it would tell you something like you need less than 100 people to detect your effect. But that's not true. That's not detecting the effect you actually care about. It's about detecting the interaction. I don't care about the interaction. This is not interesting to me. What I care about is the manipulation between my two conditions. So I need to have enough participants to be able to reliably detect that. So in that case, I powered for pairwise comparison and the necessary corrections to be able to do so, and also took into account how I would be able to reject that inferences that would be smaller than that effect. So if you see over here, I'm basically setting bounds just slightly lower than the smallest effect that I care about, and taking all this region within here as no effect that I would consider. Okay, so with that out of the way, what do the effects actually look like? So first is just the manipulation itself. Does the way you frame the question have an impact on the probabilities that people would give that the person was lying or telling the truth? So we find that no, not really. Although the evidence is kind of anecdotal, so you see that the differences are rather small. However, there is a pretty big uncertainty within this, so it makes it very difficult to determine what's going on. If I use one of these equivalence tests, what it basically tells me is I've set those bounds, and then you test the lower part of the equivalence and the higher part. Ideally, both of these would be statistically significant. If they're not, it basically says I need more data to figure out what's going on. And I had over 200 participants in total, and even that was insufficient for me to be able to determine that nothing was actually going on. Another way to look at this, which I find a bit more reliable, is using Bayesian equivalence tests, which put a bound around the same area. So it's exactly the same as equivalence test, and it just computes how much of the proportion of the posterior is within the zone of nothing is going on versus outside of the zone of something is going on. So that's what this value over here is. And in this case, you find that more of the potential effects tend to be within this zero region that I care about. So I would take this as strong evidence that nothing is actually going on in terms of my framing effect. I have the exact same thing for accuracy. In this case, the evidence is more clear in terms of most of my effect. seems to fall within the zero region. So I could basically say that I don't find evidence for a difference in terms of people's judgment and accuracy based on the framing effect that I did. And you get the same if you do signal detection theory. If I look at response bias, I get the exact same thing, where with the frequentist one, it's slightly more anecdotal evidence and it would require more data. If you quantify it with a Bayesian approach, you find that there is more evidence in terms of this effect. So as you see, this is the distribution of my Bayesian effect, tends to be very close to the zero region that I would normally reject. So that, to me, would be there is no effect on response bias based on the type of question that the way you would frame the question. And lastly, you get exactly the same for confidence, or although in this case, the evidence is much more striking in terms of there really seems to be nothing. So even the maximum effect tends to be very close to zero, showing me that I shouldn't take this as a manipulation that has an effect on judgment. So even though there seems to be a lot of research that would indicate something is going on in terms of the verbal probabilities and how it accesses people's brain, when it comes to lie detection, at least in my experiment, there didn't seem to be a reliable effect. So I would quantify this as I have found no effect, and that's exactly how I publish this. So I am a big advocate of publishing everything that you do. I'm very wary of the publication bias. I think that a lot of the research that we conduct might simply be due to focusing on published work and ignoring the fact that there might be no effects of similar things that we care about that we're missing simply because of the barrier to try to publish this. So I tried to demonstrate this by publishing this paper where I looked at no effect. So I planned for no effect, and I think I have sufficient evidence to prove that there is no effect of framing, at least in the way I manipulated it, on the outcome of people's veracity judgments. So if you want to see it in full, the paper is here, and you can scan the QR code to read it. It's very short. It's a brief report and experimental results, which is no longer a journal. Apparently, something happened to Core Cambridge for it. And if you want the data and the analysis plan, you can go on my OSF and get it from there. But thank you, and I look forward to your questions.